We're going to look at graphing linear inequalities in two variables here. And I've got a graph here already set up. This is the graph of x minus y is equal to 1. The black line going through here is. So, and if we notice, when we look at that line by itself, we know that splits the plane. It lines travel forever. So this is sort of dividing the rectangular coordinate system into two sides here. Now, everything on one side would correspond to x minus y is less than 1, and everything on the other side would correspond to x minus y is greater than 1. So when we think about that, this shading area that's over here is the area that corresponds to x minus y is greater than 1. That's what we have when we have two linear inequalities in two variables. We're looking at this from the instance of, we know in the case, say we said y is greater than 1, just to illustrate this. Well, that means if y is equal to 2, yep, that works, 3, 4, etc., etc., etc. So we have this big, huge area of numbers, or a lot of numbers that would make this statement true. Conversely, when we look at a grid and we have two variables, we have an area where both the x value and y value would make an equation true. So this whole side will line up, that shade of blue makes x minus y is greater than 1 true. If we take the other side of the line and look at it, and maybe we'll shade that orange or so, and we can put that in here. It's not going to be real pretty, but okay. And we can put that down here, and we see that that means this is blue. I don't want to do that anymore. What we're saying here is x minus y is greater or less than 1, do everything in orange, x minus y is greater than 1, do everything in blue. Now, what does this mean for us? Well, when we want to graph a linear equation in two variables, I'll do it if you will. Back last week. Alright, so when we want to graph linear inequality in two variables, we really want to think about, we want to think of it as, and I'm going to write thing of it as, say in an example where we have x minus y is greater than 1. When we think about this, we'd like to think of it as x minus y is equal to 1. Okay? Then we can look at this equation and this inequality from an equation point of view and manipulate it as such. Now, when we get to graphing, we'll look at this one in a minute, but once we graph this line, we want to make a test. We want to pick a point on one side or the other of the line and see, does that point make the equation true, or the inequality true or false? If it makes it true, then that whole side of that line is our answer. If it's false, then the other side of the line is the answer. So let's think of this. Let's look at another example. Let's say we want to graph x plus y is equal to 7. Oh, no, I'm sorry. We don't want to be equal. We want to be greater than or lesser than. So let's see. X minus y is less than 7. Okay. So let's make a graph here. And we'll go this way. Okay. So basically, what we want to think of is we want to think of this as x plus y equals 7. And we can then solve for both x and y and get our intercepts to graph a line. So we look at this. So we would have x, we put 0 in for y, so 0 equals 7. X equals 7. So we'd have 7 on the x-axis. 1, 2, 5, 6, 7. Now if we want to know what y is, we put 0 in for x. So 0 plus y equals 7. y equals 7. So y would be 7. 1, 2, 3, 4, 5, 6, 7. So this is going to be our point. We'll draw a line down through there. There's our line. We've got to wait a minute now because the line matters to us. Now I've drawn a solid line there. I don't know if I have. Let me get back to the side here. Do we have a thing? We don't have a thing for a dotted line. Okay, so one thing we have to have is if we have less than or greater than, then what we're going to have is a dotted line because it's not inclusive. Anything on the line does not make that statement true. If we have less than or equal to or greater than or equal to, we're going to have a solid line. So in this case, what I'm going to do, I'm going to try to just erase little points here to make this more of a dashed line somewhat. So there's a dashed line in a sense. Okay? So we have the graph of this. This is the graph of x minus 1 equals 1. But because we're less than or equal to in our original equation here, we're making it a dotted line since it's less than. So now we need to choose a point. Well, an easy one on one side. You know, the line goes here, so we need to either choose something over here or over here. An easy one to use is 0, 0. If we can never use the origin, we should. So let's replace this in here. We have x plus y is less than 7. If we replace 0, x was 0 and y was 0, 0 plus 0 is less than 7. That's a true statement. So if that means, if that's a true statement, what that is telling us right now is that this side of the line over here is our answer. So what we're going to end up doing is we would shade everything on this side somewhere. Everything there would be the answer. Everything on the opposite side does not fit, and anything on the line does not fit. So this is a graph of this one. So let's look at one more. We'll look at one more here. It's going to be a longer video, but that's okay. So let's look at 2x minus y is greater than or equal to 3. While looking at this, remember we want to think of this as 2x minus y equals 3 to get our intercepts. And now we can do this. We can say, okay, if y is equal to 0, we get 2x equals 3, x is equal to 3 halves. When we get x is equal to 0, what we get is negative y is equal to 3, y is equal to negative 3. So we've got intercepts here on the x and the y. So what we're going to look at here in this case is we're going to say, okay, here's our grid. Draw a grid in here. And we know we have x on the 3 halves, which is 1 and 1 half. So here's our x-intercept. Our y is at negative 3. 1, 2, negative 3 there. So we have a line that goes like this. And this will be a solid line because we have that equals to it. We have greater than or equal to it. So now we draw our line. Now we need to look at our test point. Where are we going here? Well, again, the origin is open. The line doesn't go through there, so we can pick that. Now we pick that, we're back to our original equation, 2x minus y greater than or equal to 3. So let's plug 0, 0 in here. Now 2 times 0 minus 0 greater than or equal to 3. 2 times 0 is 0, minus 0 is 0. So we're saying is 0 greater than or equal to 3. Well, no, it's not. So it means that the other side of the line has to be the solution. So we would look at doing this. We would shade the other side of this line, and that would be our solution. And to illustrate, we can pick a point on this side of the line. Let's pick this point right here. I don't know what that is. It's 3, negative 2. So we'll plug that back into our original equation, 2x minus y and 3. So we plug this in, 2 times 3 minus negative 2 is greater than or equal to 3. So 2 times 3 is 6, minus negative 2 is plus 2, greater than or equal to 3. So is 8 greater than or equal to 3? Well, that's a true statement, so we know we're correct here. So this is how we graph linear inequalities and two variables. So hopefully this helps out. And the next one we'll be looking at what happens when we have a system of inequalities and graphing them. So that'll be interesting. Stay tuned for that. Have a good day. Bye.